Okay, so we talked a little bit about the intro to the software, and now we need to talk about how to actually analyze a sample for the first time. So I have opened the lid up to the instrument, and I have put in what we would call my blank, and I have put in a sample. Now the blank is the solvent that I have decided to use. That could just be simply water, or that could be the solvent that I have used to make my stuff dissolve up in. So that could be a very weak acid, it could be a very weak organic compound. Who knows what I would need to dissolve my sample up with? But that is what we would call the blank. So I have put a blank in, which is that solvent in a cuvette, into the B mark in the carousel. And then I've also turned in a sample to the machine, and that sample is in spot number 1. Now this machine will hold up to 5 samples. So I can analyze 5 samples and a blank in one fell swoop and get the data from every bit of it. If you want to do that, then that's up to you. I'll show you how to do that in just a second. Or if you want to do them one at a time, that's also up to you as well. But let's talk about how to analyze these blanks and then how to analyze the actual sample itself. Okay, so the first thing that I want to do when I cut this machine on is go up here to the baseline tab, and I want to click the baseline, because what this allows me to do, it allows me to take the blank that I have used to make my sample with, and it's now scanning between the region of 350 to 800 nanometer. That is the window that I told it to measure with. Maybe we won't give you a window that's big. Maybe we'll give you 400 to 600 or 500 to 600. Who knows what window we'll provide you, but we will at least tell you what to actually scan when it concerns this start and end nanometer. So right now it's going through 350 to 800 nanometers. It's doing that at 1 nanometer at a time, and every single wavelength it's blanking itself out, which means it's recording the baseline. It's making the instrument read 0 here. That's what we're doing with it. Okay, so this is going to take a couple of seconds or a couple of minutes, depending on how wide of the window I have, depending on what I've told it to do, but it's going to take at least a moment. Now up here at the very top of the screen to the right hand side, you will see 800 nanometers. Well, that's where it stopped, right? It stopped at 800. And then over to the right, you're going to see 0.000A for absorbance. So this is a good sign. That means I've blanked it the right way because it is reading 0 now. The same thing is happening when you go to the balance. When you go to the balance and you put a wayboat on, you hit the tare button to make it read 0. This is my way of hitting the tare button on the UV Vis instrument. Okay, so now that it's been blanked, I can then go over and I can measure my actual sample now. My blank is not really a sample, right? My blank is for the baseline. My sample is the actual thing that I want to read. Okay, so I've inserted a sample here, and I'm going to click Measure Sample. I'm not going to change anything on the screen. Everything should be analyzed under the same parameter, right? And then here in spot number 1, remember I told you it can read up to 5. In spot number 1, it's going to want a name. Okay, so what do I want to name this? I'm just going to name this Test Run Number 1. So I'll type that in using my keyboard. The description you can leave blank, it's not necessary. And you know, I've already measured my blank, and this by default is checked. And that's okay. If I just want to go through with the whole process over again, I can. That's up to me. If I don't want to measure the blank again, I can uncheck this, right? And it will say, okay, fine, we've already blanked ourselves. We don't need to do it again, but we will. So I'll go to the software screen. I can check this box. We'll measure the blank again just to make sure it's okay. And then it's going to analyze sample number 1 for me. And then I come down here and hit measure. Now if I want it to measure all 5, I would go down and I would name each one of these differently. test 1 run 2, test run 3, test run 4, test run 5, and then hit measure. And then it will measure all 5 and kick them out onto the computer screen. So I'm going to hit measure, and then I'm going to have to wait because I told it to measure the blank again. So it's going to record the baseline one more time, and then it's going to go through and it's going to scan the sample using the same parameters. So we'll give it just a second, and we'll see what happens on our computer screen. So that process took around 2 minutes. It then blanked itself, and now instead of saying measuring baseline, it's now saying scanning. So this is symbolic of it actually looking at a sample and scanning that sample between the range of 350 to 800, or whatever the preset values up here were at the very top. So this again is going to take just a minute or two for it to go through that entire wavelength and give me some data. So again, with the power of video, we will magically hit the pause button, and I'll come back when it's done. Okay, so now it's finished, and there's this red squiggly line on my screen. Sometimes this will be really low, sometimes this will be very large, but remember I told it 1 will be the cap. So if the absorbance is higher than a 1, this graph will actually go off screen. You know, if I really wanted a better looking graph, I could rescan this, and over here to the side where it says y-axis maxima, I could change this, and I could change this to a 0.5 instead, and that would enlarge the graph up a little bit. But I don't really have to do that. If I want this to look a little prettier on the screen, the only thing that I have to do is come down here to this button that says auto scale and click it. And now it zooms in on that area of where that hump is at, or the spectra maxima, the wavelength maxima, and it zooms in on that hump and it enlarges it on the computer screen for me. So this is the power of the software. This is the power of spending a couple of thousands of dollars on a software system for the instrument, and it allows me to play with the spectra that shows up. Okay, so what this is basically saying is that it started at 350 and it started scanning the region from 350 to 800, and it measured the absorbance at every single wavelength across the board. Alright, so what it's done is that it showed me a graph, and it's saying, you know, here at 400 we start to see the absorbance go up. It kind of flatlines out a little bit. And then at 500, we see the absorbance go up even more. And then after this number, that's a hump, right? After that number, whatever that number is, then after that, the absorbance just begins to plummet, and it goes all the way down almost to 0. So it's telling me that there's no absorbances in the range of 600 to 800 any longer. All right, so when we do our measurements, this is the magic number that we're after. We're after this hump that's the tallest on the spectra, right? This is something that we've talked about in the theory portion. So according to this hump, or according to the full spectrum scan, this is the hump that's associated with the highest absorbance. So we want to know where is that hump located. So I can put my cursor over the maxima of that hump and come down to the very bottom, and I can kind of guesstimate that number, right? If that's 500 to the left and this is 600 to the right and that's 550, then I can say this might be like 530-ish, somewhere in there. All right, well, I don't need to guess. Because I've checked off the maxima here, it's going to record that maxima down here at the very bottom of my computer screen. So that's the purpose of having that box checked. So the maxima is 529 nanometers, and the threshold was 0.01 absorbance. So it's telling me that the absorbance there is 0.056. So this particular sample that I've scanned, has a maxima at 529, and the particular absorbance associated with this sample is 0.056. All right, now what do we do with this number? Well, scanning is not for data crunching. Scanning is just for me to figure out what this maxima is. That's the only purpose of the scan, right? I can't say that enough. I scan my sample, get the spectra like I see on my computer screen now, and the only reason for me to do that is to figure out what this number is. And that number is 525 nanometers. Now, for me to go on and do my actual calculations, that means my samples need to be scanned under the same number. And that number is going to be 529. So if I have 20 samples to analyze, and I'm looking for the same thing in every one of them, I'm going to make it consistent and look at 529 only for those samples. I don't want to be scanning every single one of them, right? I want things to stay consistent, and that is how we do it. So in the next video, we'll come back and we'll pick up from here, and we'll talk about how to go and tell the software to scan or to look for only that 525 nanometer.